Hi everyone. Today I will talk about three basic logical gates, and those will be the NOT gate, the AND gate, and the OR gate. But before I start to talk about these gates, I want to talk a little about the logical levels. And as we know, in digital electronics we have only logical 0 level and logical 1 level. And I want to explain what would be those logical levels in analog electronics. Now, for example, if we have 5-volt logics, then a logical 0 can be something from 0 volts until 1 volt. But a logical high level can be something, for example, something from 4 volts until 5 volts. These values I simply made up, and in real life they will be a little bit different. But in this case I only made these graphics for the purpose of explanation, so that you would understand that a logical 0 level is not exactly 0 volts, and a logical 1 level it is not exactly 5 volts, but these values are in some kind of range. Okay, and now when I have explained what are those logical 0 levels and what are those logical ones, we will continue with our gates. And what I have here, I have the truth tables of each gate. And a truth table, what this truth table shows, it shows what will be the output of each gate if the input will be as described in the input column. I will show you how we can fill out these tables in a second. Okay, let's start by our NOT gate, and the NOT gate has one input and one output. And in this input column we have to write all the possible input levels that we can have on the input of our gate. And before I do this, I will label our input A and our output Q. Now in this case it will be pretty simple, because we can have only two possible combinations that we can have in the input of the NOT gate, and this will be the logical 0 level and logical 1 level. And we can already see that if our input is 0, then the output is 1. But when we switch this input level to logical 1, the output turns to 0. And you can see that now you see the idea of this table. Here are these combinations that we can have on the input of our gate, and here are the outputs in each case. And also each gate has its own formula. And in this case, the formula that describes the operation of NOT gate will look like this. Our output Q is equal to A inverted. And in Boolean algebra, inversion is described by this kind of line. This line says that signal, what we have in our input, will be inverted. It will be totally opposite that we had in our input. For example, if we have 0 in our input, then in the output we have 1. And if we have 1 in our input, then the output is totally opposite, it is 0. Okay, now let's continue with AND gate. Let's take our AND gate. This program automatically gives 5 inputs to this gate, but we will need only two inputs in this case. Okay, I will connect our inputs. This will be the first input, this will be the second input, and this will be our output. And I will also label them as I did before. So this is input A, input B, and this is output Q. Okay, and now I want to explain how we have to fill out these two input columns, and how we can fill out these two input columns so that we would describe all the possible combinations that we can have on the input of our gate. And we have to do like this. In the first column we have to write 0, 1, 0, 1, and in the second column we have to write 0, 0, 1, 1. And these are all the possible combinations of logical levels that we can have on the input of our gate. And for example, if we would have a gate with 3 inputs, like for example in this table, then we would fill out this table like this: 0, 1, 0, 1, 0, 1, 0, 1. In the second column we would write 0, 0, 1, 1, 0, 0, 1, 1, and in the third column we have to write 4 zeros, 0, 0, 0, 0, and here we have to write 1, 1, 1, 1. And if we would have, for example, a gate with 4 inputs, then this table would be 2 times longer, and in the fourth column we would have 8 zeros and 8 ones. Okay, I hope you understood how we are filling out the table for our inputs, and let's continue with our AND gate. Okay, and now we will fill out this last column, our output column, the same as we did with the NOT gate. And in this case, again, we can already see what will be our output if both of the inputs are at a low level. At the output we will have logical 0. If we have logical 0 in the input A, and if we have logical 1 in the input B, then the output is the same as before. It is 0 if we have 1 in the input A, and if we have 0 in the input B. Also in this case we have 0 in our output, and when we have 1 on both of our inputs, then also the output of this gate switches to logical 1. And this is how the truth table for AND gate looks like. Now we have filled out our table, and also the same as before with the NOT gate, also the AND gate has a formula that will describe the operation of this gate in Boolean algebra. And the formula will look like this. Our output Q is equal to A times B. And this multiplication sign, it represents the operation of our AND gate. Now, if you will see this kind of formula in literature, you will know that if we have input A and input B, and they both are multiplied, then the output of this formula has to look like this. And now I will show you an easy way how we can memorize this third column, this output column for our AND gate. And we can think like this. We can think like we are we can think like we are thinking usually in regular algebra. And as you saw, we have multiplication sign between those two inputs A and input B. And for example, here we have our input levels, and here we have our output. And if we wouldn't know this output, but we would like to remember what were those output levels in each case, we should do like this. So in the first case, if we multiply 0 by 0, normally we would have 0. Also in this case, the output for AND gate in this situation is 0. And if we multiply 0 by 1, the output also is 0. If we multiply 1 by 0, the output is the same, it is 0. And only in this case, when we multiply 1 by 1, we have 1. So as you can see, the only thing that you have to remember is this multiplication sign. You have to remember that in Boolean algebra, AND gate is represented by a multiplication sign, and this multiplication sign will help you to memorize the output column for this gate. Okay, and now we will continue with our last gate, with our OR gate. And OR gate we have here. Also in this case we will switch only to 2 inputs, and we will connect our first input, our second input, and we will connect our output. And now we will label these inputs: input A, input B, and output Q. Okay, and now I will do the same as what I did before. First, I will fill out the input columns. Here will be 0, 1, 0, 1, and here will be 0, 0, 1, 1. And now again we can see that if both of our inputs are zeros, then the output is 0. We fill out it here. Now if we have 0 on input A and 1 on input B, the output in this case is 1. And the same is when we have 1 in input A and 0 in input B. And also in this case, when we have both inputs at a high level. Also in this case, our output is 1. And in this case, the formula for this gate looks like this. Output Q, our output Q is equal to A plus B. And also, as it was before, this plus sign represents the operation of this OR gate. And also, as before, I will show you a simple way how we can memorize the output, how we can memorize these values for output column for OR gate. And in this case, we have to think like this. We have to remember this plus sign, and we have to remember our inputs. And the principle is the same as it was with AND gate. Now, normally what would happen if we would add 0 to a 0 in a regular algebra, we would have 0. If we would add 0 plus 1, we would have 1. If we add 1 plus 0, also in this case we would have 1. And this last case, it's a little bit tricky because in a normal algebra, when we add 1 plus 1, we have 2. The result is 2. But in this case it's a little bit different because it's Boolean algebra, and in Boolean algebra we have only zeros and ones, so the highest value that we can have is 1. So you can also in this case we will have 1. When we will have 1 plus 1, the result will be 1, not 2 but 1. This is all the only thing that you have to memorize, and actually it's pretty simple, so that you would remember this output for OR gate. Okay, I have explained the basic operation for all three of these gates. I hope that this video helped you to understand the basics of digital electronics, and I hope that it will help you also in the future. Thank you for watching, and see you in the next video.